All right, welcome to the Explainer. Today we're going to demystify multithreading. And forget about staring at confusing lines of code, okay? Instead, we are going to build a chocolate factory. Seriously. And by the end of this, you'll see how this whole factory thing perfectly explains the magic of how modern software can juggle so many things at once.
Okay, so let's get into it. Imagine your program is a chocolate factory, and right now it's got just one worker. Just one. This poor soul is doing everything, mixing the chocolate, wrapping it, loading the trucks, the whole shebang. So what does a day in the life of this worker actually look like?
So in the world of programming, this is what we call a single-threaded application. It's simple, yeah? But as you're about to see, it's really not efficient when things start to pick up. So let's walk through our worker's day. First, they mix the chocolate. Great. But then, boom, they're blocked. They're just standing around waiting for it to cool. The entire factory, the whole production line, just grinds to a halt. Then, okay, it's cool. They wrap it. And then they're blocked again, waiting for a delivery truck. See the problem? Every single time there's a pause, all work stops. That right there is the fundamental bottleneck of a single-threaded program.
Okay, so it's pretty obvious, right? Our factory needs more help if it's ever going to get anything done. In the Java world, these extra workers are what we call threads, and they're what let us do more than one thing at a time. So how do we hire them? Well, there are a couple of main ways to do it.
So you've got two main options. On one side, you have the specialist. This is when you use extends thread. Think of this worker as being built for one and only one lifelong job. They can't do anything else. But then you've got the other option, implements runnable. This is more like bringing in a flexible temp worker. The task itself is a separate thing from the worker. And honestly, this is usually the way to go. Why? Because it keeps your code way more organized and lets you give any task to any worker who's free.
And you know what's cool? Putting them to work is actually super simple. First, you define the job you need done. That's your runnable. Then, you hand that job off to a new worker, which is your thread. And finally, you just call start. That's it. That's the signal for them to get to work, doing their thing at the exact same time as everything else.
But here's something to remember. A worker isn't just always working, right? They're not just hammering away 24/7. Just like in a real factory, our threads have a whole life cycle. They go through different states during their shift. It's not as simple as just being on or off.
And this whole life cycle actually makes a lot of sense. A thread starts out as new. It's like they've been hired, but they're sitting in the break room waiting for their first assignment. When you call start, they become runnable. They're out on the factory floor, ready to go. From there, they might go into timed waiting. Think of this as a scheduled coffee break, which you can do with thread.sleep. And then, when the job's all done, they're terminated, clocked out, and gone home.
So we've got more workers now. Production should be through the roof, right? Well, maybe. What happens when all of your new workers try to use the one wrapping machine at the exact same time? Yeah, you get total chaos. And in programming, we have a name for this mess: synchronization issues.
Okay, first up, you can get something called a deadlock. Just picture this. Worker A has the tape dispenser, and worker B has the only pair of scissors. Now, worker A needs the scissors but won't let go of the tape, and worker B needs the tape but won't give up the scissors. What happens? Nothing. They're just stuck, staring at each other in a permanent standoff, and the entire production line stops. Dead.
Then you've got a problem called starvation. This is, well, it's kind of sad actually. Imagine you have one really polite worker who's patiently waiting for their turn at the wrapping machine, but all these other, more aggressive workers just keep cutting in line, over and over again. Our polite worker never gets a turn. They're basically starving for that resource and can't get their job done.
And this next one, this is one of the weirdest problems you can run into. It's called priority inversion. So, picture this. You've got a low-priority intern who's taking forever to make photocopies, and they're tying up the only machine. Meanwhile, the CEO is standing right behind them, tapping their foot, waiting to print a super-critical, high-priority report for the board meeting. But they can't. The intern is blocking them. A low-priority task is literally preventing the most important job from happening. It's totally backwards.
So what's the lesson here? Clearly, just throwing more workers at the problem isn't the answer. It just creates more chaos. To prevent all this, the deadlocks, the starvation, our factory desperately needs a smart manager. And the good news is, in Java, we already have one.
And that manager is called the executor service. The best way to think about it is that it manages a whole pool of workers who are just ready and waiting for a job. So instead of you having to manually hire and manage a new thread for every little task, you just hand your to-do list to the executor service. That's it. It takes care of assigning the tasks, it reuses workers so you're super efficient, and it handles all that complicated coordination stuff for you. It just takes it all off your plate. So now your whole process gets way, way simpler. You create the manager, that's your executor service, you give it tasks by calling execute, and then, when you've given it all the jobs for the day, you just tell it to shut down. The key thing to notice here is you're not micromanaging individual workers anymore. You're just talking to the manager. And that manager is making sure everything runs like a well-oiled machine behind the scenes.
All right, let's pull all of this together. Think about the journey we just took. We started with one single, completely overwhelmed worker. Then we hired more help, but that just led to total chaos on the factory floor. And now, finally, we have a smart manager running a highly organized, super efficient workforce.
And really, that's the whole point of all this. Learning to manage multithreading, especially using amazing tools like the executor service, is what takes your program from being a slow, one-thing-at-a-time shop to a powerful, super responsive application that can juggle tons of operations at once without tripping over itself. It's pretty much the secret sauce behind almost all fast modern software.
So, I'll leave you with this one thought to chew on. Your code, it is a factory floor. And now that you've seen the chaos that can happen, and you've also seen the incredible power of having a good manager, the real question is, are you ready to be the one in charge?